So in this session, we are going to discuss the desirable properties of tool material. So you all know what is a tool? Okay, we all know what is a tool. Okay, so if you take actually the manufacturing processes, if you take the manufacturing process, it has been divided into three major categories. Okay, so one is a positive process, another one is zero process, and the third one is the negative process, or we can call it as a subtractive process. So all the manufacturing processes, okay, whether it is turning or additive manufacturing or welding or forming or anything, okay, so everything will be categorized under these three categories. Okay, so first let me just give you an example for zero manufacturing process. So first of all, what is manufacturing? Okay, what is manufacturing? So manufacturing is the process of converting a raw material into useful product. Okay, or manufacturing is the value added process. Okay, so for example, if we just uh, take the rice. Okay, so just take a rice. Okay, it doesn't have any value. Okay, so for example, if you take a 1 kilogram of rice, okay, it cost is around 40 rupees. Okay, for example, if you just convert that rice into a idli, okay, rice and black gram into idli, so you can sell it for a high price. Okay, so this is what the value added. Okay, the rice is soaked in the water, then rice will be grinded, and again rice will be cooked, and we will get a idli. Okay, if you sell it idli, so you can get a more money. Okay, so this is actually the value added process. So this is what happening in all the engineering in manufacturing. So what happening in the manufacturing? First, we will procure the raw materials. Then some of the operations will be carried out on the material. Then we will get the final product. Okay. So if you compare the price of the raw material and price of the final product, then there will be a huge difference. Okay. So this huge price difference is known as the cost of value. Okay. So this is the value added cost. So since we have been discussing the manufacturing processes, there is a three type of manufacturing process. As I said earlier, one is the zero manufacturing process, in which neither material added nor removed from the raw material. Okay, so whatever the material we got, okay, we take for the manufacturing process, only the shape and size will be changed. Okay, so we are not going to add material into it, or we are going to remove the material out of it. Okay, so we just going to change the shape of the material. That is a zero manufacturing process. So all the forming operations are comes under zero manufacturing process. So forming operations means the forging, rolling, extrusion, wire drawing. Okay, so these are all the forming operations. Okay, where the material is neither added nor removed from the raw material. And the another type of another example for zero manufacturing process is called casting. So the casting is the primary manufacturing process. If you take any manufacturing operations, you need a raw material. Okay, so this raw material is derived from the casting operation. So that's why the casting is called as the primary manufacturing process. Okay, so for example, in forming operation, for example, forging operation or rolling operation or wire drawing operations, you need a raw material. For extrusion operation or welding operation, you need a raw material. Okay, so the raw material is getting from the casting process. Okay, so in casting process, what we do is we just take the raw material in solid state. Okay, then we will put the raw material in the crucible, then we will heat it. Okay, so once the temperature reaches above the melting point of the raw material, okay, the raw material will start melting. Okay, that is it will be converted into solid, converted into liquid form from the solid phase. Okay, so as we all know, the liquid, so liquid has the tendency to take the shape of the container. Okay, so the molten liquid will be poured into the mold cavity. Okay, so that the liquid, the molten liquid, will take up the shape of the mold. Okay, once it's solidified, we will get the final product. Okay, so here also we are not going to add material or remove the material Okay, so forming and casting is the example for zero manufacturing process. Okay, next, the additive manufacturing process. So here we have the raw material, And the raw material is some of the additional material is added to the raw material to produce the final product. The example is the welding process. So welding is normally a joining process where the two components or the two materials will be joined by the application of heat, pressure. In some cases, both heat and pressure will be utilized. Okay. So here in the welding process, besides the raw material, we are using filler materials. Okay, so filler materials is in the form of electrodes. Okay, so we use the filler material to join the gap between the two material. Okay, so this is the positive manufacturing process, and the additive manufacturing process also comes under this category. Okay, so we will discuss about the additive manufacturing process coming lectures. And the third category is the negative manufacturing process. So this is where the tool and all will comes. Okay, so in this negative or subtractive, you can call it as a subtractive manufacturing process. Why it is a subtractive manufacturing process? Because we'll be having a raw material that is in the oversize. Okay, and the unwanted portion in the raw material will be removed so that we can get the required shape. Okay, so for example, so this is the shape of my final product. Okay, so which is in the form of a dog bone shape, and this is my raw material. Okay, so I need to remove this portion. Okay, I need to remove this particular portion so that I can get my finished product. Okay, so in order to remove the unwanted portion in the raw material, we need a tool. Okay, we need a cutting tool. Okay, so then only we will be able to remove the material. Okay, so here only the cutting tool comes into picture. So not only this particular operation, so there are in subtractive manufacturing process, there are n number of operations are there. Okay, starting from turning, phasing, sampling, knurling, grooving, drilling, milling, gear cutting. So there are n number of operations are available. If we take any kind of product, okay, so at some case, at some point of time, it might have undergone the subtractive manufacturing process in some cases. So the polishing, grinding, okay. So all are comes under the negative subtractive manufacturing process. Okay. Now it has come to this topic, that is tool material. Okay. So the tool may be in different shapes. Okay, for example, in turning operation, the tool we use the single point cutting tool. For drilling operation, for hole making process, we use multi-point cutting tools. Okay, and for milling operation, for we use the end mill cutters and the gang milling. There are milling operation itself. There are many types of cutters are used. Okay, and in gear manufacturing, different techniques are utilized. For example, gear milling, gear cutting, gear forming, gear shaping. So there are many different processes are used. Okay, so based on the process, the different types of tools are also used. For example, gear shaping operation, we use a gear like cutting tool material. In gear hobbing process, we use the hob. The special tool called hob will be used. It has uh, spherical tools over its periphery. Okay, so based on the process or based on the requirement, the different tools will be used. So the tools, the sizes may, shape may vary, but the tool material. So the tool material is somewhat, for example, the drill bit and the single point cutting tool and animal cutter, we use same kind of material. Okay, so in this session we are going to discuss the desirable properties of a tool material. Okay, so desirable properties means it's a property of an ideal tool. So if it is a tool material, it must possess the following properties. Okay, so first property is hardness. So the first property is hardness. So what is hardness? Okay. So in the subtractive manufacturing process, the very important thing is, so every mechanical engineer must know that the hardness of the tool must be higher than the hardness of the workpiece. So then only the tool will be able to remove the material from the workpiece. So if it is in the opposite way, there won't be any material removal in the workpiece. Okay, so the tool removal will happen. So material removal will happen in the tool. So that is not desirable. Okay, so the tool must have the high hardness than the workpiece. Okay, so the hardness is the surface property, or we can define the another way. It is a resistance to plastic deformation, or resistance to indentation, or resistance to penetration, or resistance to scratch. Okay, so overall, hardness is the surface property. Okay, and the second thing is, and the second important property is hot hardness. What we call hot hardness. So what is this hardness? So we just saw what is hardness. Okay, it is a resistance to scratch. Okay, the tool material should not undergo any type of penetration, any type of scratch, or should not plastically deform. Okay, that's why the hardness property is important. And the hot hardness. So what is hot hardness? So we all know when the temperature. So this is the temperature, strength, hardness. So temperature hardness graph. Okay, the temperature increases. Okay, the hardness will decrease. Like for example, room temperature, the material will be having high hardness, and if the temperature increases, its hardness value will be diminishes. Okay, so and during the manufacturing operation, there will be a heat generation. A huge amount of heat will be generated, and the major portion of the heat is carried away by the chip, but the the another portion of heat will be accumulated in the workpiece itself, workpiece and the tool itself. Okay, so when the temperature increases, the material will lose its hardness. If the material loses its hardness, means it becomes soft. Okay, so when the tool becomes soft, it won't remove, it will not remove the material from the workpiece anymore. Okay, so even at elevated temperature, the tool material should retain its hardness. Okay, this property is called hot hardness or red hardness. Okay, and the third important property is strength. The third important property is called strength. Third important property is called strength. So strength is the ability of the material to withstand the load without any plastic deformation. So that is strength. So during the manufacturing operation, say this is the tool, this is the workpiece, and here we have a tool. Okay, so the tool is so this is the tool. Now the tool is touches the workpiece, and so the tool will be moving in this direction, and the workpiece will be rotated. So in this way. Okay. So when the tool and the workpiece interact, so when the tool touches, there will be a huge, what do you call the mechanical, the interaction will happen. Okay. So the tool has to move in just opposite to the workpiece. Okay. So you are going to apply a much amount of load to the tool. Okay. So the tool should not break. Okay. So the tool has to withstand the load. Okay. So this property is called the strength. Okay. The strength is very necessary, very important for a tool material. Okay. And the fourth one is the sphere, the strength means the tensile strength. Okay. So the tool should not bend, or the tool should not break. Okay. The strength, you can call it as a strength or stiffness, or stress. Okay. So it should have a high amount of stiffness, high amount of strength. Okay. Then the fourth property is called toughness. So what is toughness? So it is also another important mechanical property. For example, I'm going to take three different types of material. One is a steel, okay, one is a steel, and another one is the cast iron, and third material will be the aluminum. And third material is going to be the aluminum. And this is the stress strain diagram for steel, and this is a stress strain diagram for cast iron, and this is the stress strain diagram for aluminum. Okay. So now from the stress strain diagram, so most of the many mechanical properties can be interpreted. Okay, for example, this is the elastic limit, proportional limit, then this is going to be the elastic limit, and this is the upper yield point, this is lower yield point, this is the ultimate point, this is going to be the breaking point. Okay, and if we take a um, and if we go into if we take the stress strain diagram for cast iron, so here you are having ultimate point and breaking point. In most of the cases, the ultimate point and the breaking point will coincides. Okay, and this is the stress strain diagram for the aluminum. So and here also it has a separate yield point. It has a separate yield point, ultimate point, and breaking point. Yield point, ultimate point, and breaking point. Okay. Yield point, ultimate point, and breaking point. So now, how will you identify the toughness of the material? So here the toughness is the ability of the material to absorb the energy till the fracture. Okay, so this is called as the toughness. Okay, so here we just draw a vertical line from breaking point towards the strain, that is the x-axis. Okay, now we'll get a closed entity. Okay, if we measure the area of this closed entity, this is called as the toughness. Okay, the area under the curve is called toughness. Okay. Toughness. So this is the area under the curve is called toughness. Okay, and if you measure the toughness of steel, cast iron, and aluminum, so each material having different toughness values. Okay, for example, if you compare these three materials, the steel will be having the high toughness. So it has a more toughness, and aluminum it stood in the second place, and the cast iron is in the third place. Okay, so the steel has more toughness than aluminum, and then third the cast iron. Okay, so the toughness of the material is very important because the material doesn't have toughness, so it will easily fail. Okay, so the toughness, the tool material should have a toughness to absorb the energy. Okay, because during the interaction, if you are moving a tool against the workpiece, so there will be impact. There will be impact load or impact load will be applied over the tool. Okay, so if the tool doesn't have the sufficient toughness, so it may easily break. Okay, so the tool material should have enough toughness to absorb the impact load. Okay, and the fifth property is called thermal conductivity. So why a tool material should have a thermal conductivity? Is there any relationship with thermal conductivity with the tool material? Yes, of course. The tool material must have the high thermal conductivity. Why a tool material should have a high thermal conductivity? As I said earlier, during the manufacturing, during the machining operation or the turning operation, so there will be a lot of heat generation. So heat is generated at three places. One is the shear zone, where around 70% of the heat will be generated. Then to the workpiece interface, then to the chip interface. So these are the three places where heat will be generated. Okay. And the generated heat, the most of the huge quantity of heat is carried away by the chip, whereas the remaining heat is accumulated, remaining heat is absorbed by the tool material and the workpiece. Okay, and if you compare the temperature of workpiece and tool material, the tool material has more temperature, so it has a high temp. It is in the high temperature. So this is because the tool is always in contact with the workpiece. Okay, so the tool material should have a sufficient or should have enough thermal conductivity so that it can dissipate the heat. Okay, so that it will be in a constant in a it will be withstand its hardness and strength. Okay, as you all know, the strength in sorry, the temperature increases, then strength and the hardness will decrease. Okay, but the toughness will increase. But the toughness is not going to be um, not, is not going to be helpful for cutting operation. Okay, for cutting operation, this the hardness is very important. But the strength increases, the hardness will decrease. Okay, so the tool material should have a thermal conductivity so that it will be able to dissipate the accumulated heat. Okay. Then the sixth important property is wear resistance. Sixth important property is called wear resistance. So whenever there is a interaction between the two material, okay, so there will be a material loss. Okay, the material loss maybe material loss maybe takes place. Which material will be having a minimum strength or minimum hardness? Okay, for example, um, I'm going to rub two material. Okay, so I'm having a material A and material B. I'm going to rub these two materials together. Okay, now the material interaction will take place, and the material is A is having high hardness and material B is having low hardness. Okay, if I just cross each other, okay, the material from the low hardness material will lose its material, and the the high hardness material will take up the material from the low hardness material. So here the two material will be acting as a tool and the workpiece. Okay. So wear resistance is a very important property of a tool material, because you may ask, sir, already the tool is having high hardness, but how does the tool wear? Okay, how the tool wear happens? Okay, as I said earlier, there is a temperature which plays the important role in the wear resistance. Okay, so at the rack phase, okay, so this phase is called as the rack phase. So the tool will be the tool will be removed from this space. Okay. Sorry, the chip is going to be froze over the rack surface. So the tool is taking a more amount of heat with itself. Okay. So the high temperature chip is flowing over the rack surface of the tool. So there is a continuous upgrading action or continuous sliding action over the tool material. Okay. So the tool wear will happen in a prolonged time. It will not happen at as soon as you start the turning operation. So it will take some time. Okay, when the tool the temperature of the tool increases, then the tool becomes soft. Okay, at the same time, the chip is flowing over the surface of the tool so that it will remove the material. So the tool wear cost is an important cost when considering the economics of machining. Okay. So wherever possible, we have to reduce the tool wear. Okay, because the cost of the tool is very high. Okay. And the seventh important property is what we call the corrosion resistance or chemical inertness. It is called the corrosion resistance or chemical inertness. So why the corrosion resistance is important? Because during the machining operation, so there is a heat generation and there is a lot of friction. So in order to minimize the effect of heat and minimize the friction, we use coolant or lubricant in the manufacturing process. The coolant could be a mineral oil, or it could be a soap oil, or it could be a fatty acid, or anything. Okay, so it may spoil the workpiece or it may spoil the tool. Okay, so the tool material should have enough corrosion resistance to overcome the attacks of the cutting fluid. Okay, that's why the corrosion resistance is considered to be a important property of a tool material. Okay, so you may ask, sir, you may ask, so if you take any kind of tool, will it have all these seven properties? Okay, so definitely not. Okay, so if you take HSS steel, uh, so it has a good toughness, hardness, everything, but its red hardness is low in compared to the ceramic material. Or if you take a ceramic material, its hardness, red hardness, um, wear resistance, corrosion resistance, so all are good, but the ceramic material lacks that toughness. Okay, it doesn't have a toughness or it doesn't have a tensile strength. If you apply a huge load or ceramic material, it will straight away break because ceramic materials are brittle materials. Okay, so we cannot expect the tool material to have all the 7 properties. Okay. So some tool material may have 6 properties out of the 7, or some may have 4 properties out of the 7. So so the tool material should have a hardness. Okay, that is the primary property. Okay, it must have hardness. So all other properties may be compensated by adding some kind of um, accessories or accessories. Okay. So now we are going to discuss the high speed steel. Okay, so this high speed steel um, is shortly called as HSS. Okay, if you go to your lab, okay, your machining lab or workshop, okay, you can find the HSS steel in all the lathe machines. Okay, so in our laboratory, in our workshop, we'll be using mild steel as the workpiece for all the operation, whether it is a turning or anything, or milling or anything, we'll be using mild steel as the workpiece. Okay, in order to machine a mild steel, we are using a high speed steel as a tool material. Okay, why this name high speed steel is given to this particular category of steel? Because if you classify the steel, okay, actually the steel is an alloy of iron and carbon, and the carbon is positioned interstitially on the iron lattice. Okay, it is a steel is a solid solution. It has iron and carbon. Okay, so based on the carbon composition, okay, the steel is majorly classified as um, carbon steels and alloy steels. So in carbon steel, carbon is the major primary alloying element. Okay, or it is the only alloying element. Whereas in alloy steel, so in addition to carbon, there is another alloying elements are also added to it. Okay, so again, this carbon steel is classified into based on the carbon composition. It has been classified into low carbon steel, medium carbon steel, and high carbon steel. So in low carbon steel, the carbon percentage is in the order of 0 less than 0.3 percentage, and the medium carbon steel is having 0.3 to 0.6 percentage carbon, and the high carbon steel contains 0.6 to up to 2 percentage carbon. So practically, the high carbon steel will not have a 2 percentage carbon, so its carbon content is limited to 1 percentage. Okay. If you add a 1 percentage carbon, so it will induce the more strength and more hardness and more brittlness. Okay, so we will not add up to 2 percentage carbon in the high carbon steel. Okay, so the high speed steel, okay, it comes under the alloy steel. It comes under the category of alloy steel. So this high speed steel contains 18 percentage tungsten, 18 percentage tungsten, and 4 percentage chromium, and 1 percentage vanadium. Okay, so now why we have to add tungsten, chromium, and vanadium? So this is the next question. Okay, so in the desirable properties of a material, so I have listed 7 important properties, starting from hardness, hot hardness, strength, toughness, thermal conductivity, air resistance, and corrosion resistance. Okay. By adding this particular ingredients to the iron, okay, it will be having, it will impart hardness, hot hardness, and strength, toughness, okay, to the iron. Okay. So this first let me just give you an give you an overview about the tungsten. So tungsten, you can find tungsten in the electric bulb. Electric bulb. Okay. So in the electric bulb, you will be having tungsten filament. Okay, there is a filament inside that bulb. Okay, so that filament is made up of tungsten. Okay. So the tungsten is having, tungsten has around 3,410 degrees Celsius melting point. Okay. It is that is 2 times more, 2 times high melting point compared to the steel. The iron has 1,539 degrees Celsius as melting point, whereas the tungsten has 3,410 degrees Celsius the melting point. Okay, so by adding the tungsten, 18% tungsten to iron, it imparts hardness, and other toughness and all. Okay, and 4% chromium is added to it to import hardness, and corrosion resistance and wear resistance. Because the chromium has the tendency to combine with carbon to form chromium carbide Cr23C6. Okay, so this this intermetallic will be precipitate along the grain boundaries and the grains, so that it will impede the dislocation motion, so that the strength of the metal will be improved, as well as the corrosion resistance. The chromium is known for its corrosion resistance, so that it will impart corrosion resistance to the tool material. And the 1% is where 1% vanadium is added to it to impart the strength, wear resistance, and also vanadium is also have a tendency to form a vanadium carbide. So with this, we wind up this class, and we will discuss the remaining things in the next class. Thank you for joining.